Hello guys! In this video we're going to go over some of the most basic differential rules that we have. So in the last videos we were talking about the definition of a derivative and how to find it using that definition, the limit as h approaches 0 of f of x plus h minus f of x all over h. So now we're basically going to learn some shortcuts. So first shortcut is when it comes to constant functions. So the first, we can say that f prime, or the derivative of f, or the first derivative of f, well, we can also write this as d over dx. This is the derivative with respect to x. So the first derivative, in fact, of with respect to x, and we'll get to more complicated things later. When you are dealing with a constant function, so just constant c, just like this negative 15 here, the derivative is going to be 0 every time. Now think about the reason why. If you have a constant function, y equals negative 15, that is going to be a perfectly horizontal line of the graph. And the slope of a perfectly horizontal line is 0. So this makes perfect sense. We just have to know the notation in which they're going to be using it. So if you have a constant function f, then its derivative will be 0. So any constant derivative will be 0. So the next rule that we're going to work with is called the power rule. Now the power rule we have works mainly with polynomials, but we'll get to the rest in a minute. It works anytime you have a power of the function. So in this case, we would want the derivative of some x to the n, where n is a power. So the derivative in this case, we're going to pull that power out front, and then we're going to go down a power. So what this is going to look like is we're going to have the power in front, and then the new power will be n minus 1. So in this case, g of x, this power here will go in front. So 3 times 4x, and then the new power will be down 1 power. So this will be 3 minus 1 for the new power. If we multiply this all together, we get 12x squared as g prime, the first derivative. Okay, so when you have a power, you're going to pull the power out front, and then you're going to go down a power. The derivative for e. E is fun. Anytime you have e to any power, doesn't matter what, the derivative is the exact same thing. There's no weird tricks to e. What you see is what you get. No problems. Okay? So the derivative, h prime of x, would be e to the 7. No weird stuff, no changes. Because of what e is, it's a number. So as long as you're talking about the domain, and you're staying in the domain, and the domain is all real numbers, then there's no problems. The derivative works just fine. So what if we have more than one thing in our derivative, or in our function? Well, that's not a problem. If you have f of x plus or minus g of x, then all you got to do is same thing for the derivative. So if we take all these pieces, which if you noticed, we actually found above, then the derivative of k of x will be the derivative of f of x plus the derivative of, oops, excuse me, that was g of x, wasn't it? That's h of x and f of x. No problems. So, that would be 12x squared for the g prime. We have plus e to the 7th for h prime, and 0 for the 15. String them all together. And there we are. No problems. So basically, unless something goes funky, the derivative rules, these first few, are not that bad. The derivative of any constant is 0. The derivative of e to the x is e to the x. And if you're dealing with powers, you pull the power in front and you go down a power. So let's do this again. So, 5x. This would fall under the category of the power rule. So we're going to pull the power in front and then go down a power. Well, what's the power when we don't see a power? 1. So take the lovely power, pull it out front. So that would be 1 times 5x, and then the new power, you go down a power. So that'd be 1 minus 0. Oh, excuse me, 1 minus 1 for the new power. So that would be 5x to the 0. Anything to the 0 power is 1. So f prime would be 5. So once again, that's a shortcut. If you go down a power and the only power you have is 1, then you're just going to have the coefficient in front. Alright, how about this one? This one is also the power rule. Power goes in front and then you go down a power. The problem is you have to remember that square root is a 1/2 power. Anytime you have a root, it's a fraction exponent. So if you have any radical with the index and the exponent, becomes a fraction exponent. So the square root of t becomes 12t to the 1/2 power. So the power comes out front, and then we go down a power. So 1/2 times 12t, and then down a power, so 1/2 minus 1 will be the new power. So 1/2 times 12 is 6, and then t 1/2 minus 1 is negative 1/2. Negative powers mean they're in the other spot. So if they're in the bottom, they become positive in the top. If they're negative in the numerator, like this one is, then to make it positive, we have to shove it in the bottom. So it is now in the denominator, so it is positive. And we can also put that back into a radical. All three of those forms are mathematically mean the same thing, because math doesn't care what form it's in as long as it's accurate. So all three of these actually mean the same thing. But the one that we see the most is actually the last one, because there's fewer confusions with it. we don't like negative exponents. So even though this first one is accurate, well, we just don't see it that often because we hate negative exponents. That is a human thing, not a math thing. It's notation, or convention, tradition. Depends on how you want to look at it. Alright, let's do another one. Okay, so this one, once again, it's the power rule, and this time we have 3 separate ones, but it's still the same thing. So the power comes out front, and then we go down a power. The power comes out front, and we go down a power. The power comes out front, and we go down a power, every time. So, 6 times 3x to 6 minus 1 as the new power. Then minus 5 times 4x to the 5 minus 1 as its new power. Then plus 1 times 24x. The power when we don't see a power is 1, minus 1, going down a power. And simplify. So 6 times 3 is 18, x to the 5th, minus 20, x to the 4th, plus 24, x to the 0. Anytime we have a 0 power, turns into 1. So the first derivative of h is just like this. And there we are. Now, I've said first derivative several times. That implies that there is possibly other derivatives, a second derivative, or even a third derivative. And yes, indeed, there are. And they use the same rules. The only difference is the rest. So, we'll get to that in a minute. Let's find the derivative of f of x of this lovely thing. Well, we don't know how to do this the shortcut way yet, so we're going to have to simplify f of x first. So go ahead and multiply that. So that would be 30x cubed plus 25x squared plus 36x plus 30. Alright, so now that I have that, I can find the derivative. So, pull the power out front and go down a power. So 3 minus 1 would be squared. Pull the power out front and go down a power. Pull the power out front, go down a power. Derivative of a constant is 0 every time. So we have 90x squared plus 50x plus 36. And there we are. The more you practice, the faster you'll get. For now, go it the long way. The fastest way to a headache in math class is to try to do it in your head. Practice makes perfect. And in math class, your homework is your practice. You do it, and then you do it again, and then you do it again, over and over again until you got it down. Alright, let's do another one. We have this lovely thing. There is a shortcut, but we don't know it yet, so we're going to do it the long way. The first would be to simplify. We don't know how to do any derivative except for constants and powers, polynomials. So, simplify individually. We're dividing by a monomial, so we can split up that denominator into 2 pieces. So that's 9/5 w to the 7th minus 7/5. So now we can find the derivative. G prime. The power goes out front and go down a power. For a constant, the derivative is 0. So that goes away. 7 times 9 is 63 over 5, w to the 6th. And there we are. We will learn all sorts of shortcuts to make our life easier. But for now, one step at a time, use what you know. So simplify the function and then find the derivative of each term individually. So now let's look at possible higher derivatives. So these things, you have the first derivative, the first derivative with just 1 tick mark, the second derivative with 2 tick marks, the third derivative. Notice that the 3 here is in parentheses. That's how you know it's a derivative and not an exponent. You could also see it as 3 tick marks, and it would mean the same thing. So, our lovely function here, power rule every time. So we take the power, we pull it out front, and we go down a power. So the first derivative would be 5 times 8x, go down a power, so that's to the 4th, plus 3 times 4x, down a power, plus 2 times 6x, down a power, would be to the 1st. So 5 times 8, 3 times 4, and 2 times 6. There we go. And we can leave off that one exponent because we don't like looking at it. So for the second derivative, we're going to take the derivative of the first derivative. Okay? So, pull the power out front, and then go down a power. 4 minus 1. We're just doing it again, really. So pull the power out front, and go down a power. Pull the power out front, and go down a power. So, there we go. So I just took the derivative of the derivative. For the third derivative, I'm going to do it again. I'm taking the derivative of the second derivative. So, 3 times 160, go down a power. 1 times 24, go down a power. Derivative of any constant is 0. 3 times 160, actually don't know that one off the top of my head. So, calculator time. Anything to the 0 power is 1. And 0, of course, goes away. So anytime you're talking about higher derivatives, you're really just talking about taking the derivative of a derivative, which is the exact same thing we've been doing. You just do it again.